Okay, we're supposed to evaluate the sine of theta minus phi given these conditions, that the tangent of theta is 3/4, that theta is in quadrant 3, that the sine of phi equals negative square root of 10 over 10, and that that angle is in quadrant 4. So here's a picture of what's happening. If I take theta into the third quadrant, quadrant 3, and say that the tangent of that angle is 3/4, opposite, this is the reference angle right here. Let's see, reference 1. The tangent of that angle is negative 3 over negative 4. And by the Pythagorean theorem, this is the hypotenuse of that little reference triangle. And for phi, which we're rotating into the fourth quadrant, we could get there in the positive direction or the negative direction. We're told that the sine of phi is negative square root of 10 over 10, so opposite of our hypotenuse. By the Pythagorean theorem, if you had to solve it, x squared plus negative radical 10 squared equals 10 squared or 100. And if you simplify that and solve for x, you get either plus or minus 3 radical 10. We're in the fourth quadrant, so the cosine is positive. And now you have enough information to use this trigonometric identity. The sine of x minus y is same as the sine of x cosine of y minus the cosine of x sine of y. I wrote this second term in a different order, but it's the same thing. So there are the values from the diagram. Just substitute those in, simplify. And here's what a simplification might look like. There's the sine of theta times the cosine of phi minus the sine of phi times the cosine of theta. And you can see these all lead to the same result. By the way, to get these values, I did actually say that theta sub 1 equals the inverse tangent of 3/4 and put the angle in the fourth quadrant or third quadrant. But simplifying, you get this, and finally there's your exact answer, negative 13 times the square root of 10 over 50. There you go. Hope that helped. If you have any questions, post a comment.